Hello, everyone. Welcome to Brenmiller Energy webinar. My name is Brenmiller. I'm Chief Operating Officer for the company and a co-founder. And we are extremely excited today to share some general update with you, but mainly we are here to launch our next generation technology and product, the BGen Zero. The technology and update will be presented today by Doron Brenmiller, Chief Business Officer for Brenmiller Energy. So without further delay, Doron, take it from here.
Hello, everybody. It's a pleasure to be here, and thank you for joining to hear some exciting updates about our product. So first of all, let me share the presentation with you. As Nir mentioned, we are here today to announce the new generation of our technology development, the BGen Zero. A bit of background and a short disclaimer before we get to business. So I'll give you a few seconds or a minute to go through this slide, make sure that you read carefully through the disclaimer before we carry on with the presentation. So a few general words for guys who are not familiar with what we are doing. We are a company focusing on thermal energy storage. We are one of the leading companies, or one of the most experienced companies out there today. And we have been doing this since 2012. Invested a lot of time and money to develop our technology based on many, many years of experience of our team members. We are based out of Israel, and we are today traded in the Nasdaq and Tel Aviv stock exchanges. We have about 60 employees between our head offices and production manufacturing floors. We installed already 4 projects globally using this technology in the US, in Europe, in Brazil, and in Israel. And we have recently also entered in the last years to strategic partnership to expand and support our global growth. What we are doing is decarbonizing heat. And in a minute, I'll tell you why heat. We see heat as the lowest hanging fruit today in the world of decarbonization, in the world of net zero. Heat accounts for about 51%. So thermal energy heating and cooling is about 51% of global emissions and global energy consumption. Listen to this number, 51%. We keep talking about electricity, and it's a very important part of producing renewable and clean electricity, but it's only 17% of what is actually being consumed and what is actually generating the emissions. So we are working on this 51%, which is still quite untreated. And heat out of this thermal energy is the single largest segment or part that still haven't been significantly decarbonized. This is where we are targeting with our technology to help this major segment decarbonize, which is something critical we need to reach to net zero. Now, I'm not going too deep into the numbers, but if you look at this very interesting slide, which came out last year from a McKinsey report, you can see what are the alternatives today to create clean, green steam or heat. So if we compare to the baseline of a gas boiler, which is what is predominantly used today to generate heat, we can see that almost every alternative we have in our minds today, from biomass to hydrogen to carbon capture, is in most cases more expensive than the alternative today. And also, in some cases, also far into the future, because we still have many challenges, for example, when it comes to hydrogen, to transport hydrogen efficiently, to make it really clean and green. But it's interesting to see in this report that the test thermal energy storage alternative here to create clean steam is actually the most also attractive one in terms of numbers, especially when we are targeting higher conditions of heat or steam for the industry. A test coupled with electrical charging, and we're going to talk much more about it today, is perceived by McKinsey as the most competitive alternative to fossil fuels, both in terms of cost and, of course, in terms of reducing emissions. So again, we are very focused on decarbonization of this critical part, the heat or the steam. Now, it's not only McKinsey. Many countries around the world recognize the fact that we have to tackle this difficult part of heat and to electrify it or decarbonize it. And this is why we are starting to see more and more regulation and more countries going in and providing supportive regulation and funding and grants to enable us to do that. You can see here the examples from Spain, from the US, New York. You can see it also in California, and overall also federal support coming from the DOE, especially for this specific purpose of financing project which decarbonize heat in the industry. So this really helps our projects. Almost every project that we have is standing by itself, but also being supported financially by those grants and those supports which enable us really to electrify and not just save or reduce emissions, but also reduce the cost and save money to our customers. Now let's get to the main part of what we wanted to say today. So some of you might have heard in the past about different projects that we did, different products. It took us a few years to really fine-tune the technology and really find the segment that we think is the most important or the most central to decarbonization of heat. And we use these years to test, and as I said before, validate the technology, experiment on different markets with different applications of the technology, and learning from these experiences, taking all this accumulated know-how, we took all of it and put it in our new product, the BGen Zero, which is built on our core technology, the BGen, the thermal energy storage models, but it's focusing on one central application that we feel is the key to decarbonization of heat, and this is electrification of heat. So taking these technology, charging with clean green electricity, heating up the models, and then discharging clean and green steam, hot water, hot air, everything on the thermal side that the customer needs. And we do it in a very unique way. In this application, we really minimize emissions. We do not need to burn anything. We don't need to emit anything. We do it in a very smart, efficient, and modular way. Competitive and low cost. We are using materials here that will last basically forever or for many, many years with minimal degradation, a very simple operation maintenance. We are putting this to last for life. It's not something you need to replace every 3-5 years. It's something you put there and they give you clean and green steam for many, many years. And the focus here again on this product is increasing and improving the qualities required to electrify heat or electrify steam. Now, quick reminder, how does it work? So we take in this product electricity. Electricity can come from different renewable sources, wind, solar, grid, and I will talk more about also a new business model that we are working on, which is providing grid services. Not only do we supply clean heat, but we also supply significant relief and services to the electrical grid, and as a result, also additional revenue streams to our project. And we'll talk more about it down the road. You can see here in the circle how it looks. We are taking electricity, clean electricity, converted it to high temperature heat using embedded electrical heaters. This is a very efficient way to charge the storage. Almost no or minimal losses in this way of charging. We are heating up, and then when we need to supply the energy to the customer, we are releasing in a different cycle steam or heat, And this is completely decoupled. So we take the renewable power, or we take the grid power when it's available, when it's clean, when it's cheap, and then we dispatch the steam or heat really according to the demand profile of any industrial or commercial client. You can see here how it looks. Now, let's talk about numbers. What did we improve in this generation? Because there are different approaches, but I think the numbers here are very important to understand the investment that we make within the technology in the last years and what brought us here today. So first of all, as we are saying, in this application, the central one, we are talking about 100% electricity for charging. Secondly, we are talking about increased charging power. A charging power is one of the most important elements in thermal storage. When you electrify heat, you want to have the maximum ability to reduce load from the grid, to take in power as fast as you can, also to enjoy, renewable when you have it, lower tariffs when you have it, and really utilize the system to the best of the ability. And in this new version, we increased the charging power in around 40%. Another thing that we did regarding charging is to improve the charging time or a response time of the system. To be able to do what I said, provide very quick response to the grid needs, we need to be able to charge the system and take it on and offline very quickly. We need to get in a second an order from the system administrator, from the TSO, and then charge the storage. Very similar to what a battery does, but today we are also playing in these markets that were saved more for other types of technologies. We have the ability to really reduce load very fast. And in some cases, as I said, this becomes a very important revenue stream and service for our projects. So we provide a relief to the grid, we act very fast and take a lot of energy in a relatively short period of time to charge and heat our unit. Secondly, we improve the efficiency. So energy density, which is one of the more important parts when you measure storage performance of thermal storage, is how much energy we can dense in a certain unit of volume. And we improved our density, and as a result, how much energy we can store in a given unit in 34%. And of course, this also reduced the cost as a result of per megawatt of our solution. We significantly reduced our heat losses, which is also a critical parameter with thermal storage, in about a third. And we reached very impressive charging efficiency. And this is a very important parameter for our technology. Most technologies out there are not using the same method to charge the storage, the embedded electrical heaters you've seen before. By using these embedded electrical heaters, we get to over or around 99% charging efficiency and around 97% complete cycle efficiency, from power up to heat, very minimal losses, a very efficient use of the power. And this is very unique to our product, and we're really able to maximize this parameter in the last Vision Zero design. A few more critical and important parameters are improved discharge power. So in order to really maximize the value of the system, we also want the ability to have the option to give very high peaks of energy. So even if a customer has different fluctuating demands and relatively high peaks, we can really squeeze the storage and get to very high peaks from the same unit. Again, very important parameter that we have three main ones: charging, capacity, and discharging. And all of them were improved in 30 to 40%. A very big step up in terms of all these parameters, which enable us to, again, offer a more economic solution, less cost per megawatt hour, and more value out of the system. And a couple of other parameters we really worked hard is the availability. So customers, depending on such solutions, want to have high availability. They need this to service their hospitals, their manufacturing lines. They don't want something that one component breaks and the entire system stands still until it's fixed. Because we have multiple parts, the system is very, very built in very redundant way, many heaters, many modules. We can work, few items can fail like electrical heaters, and we can continue to work very nicely and just stop for scheduled maintenance. So this allows us to get to this very high number of availability. And we also maximize the prefabricated components. We want to be in and out fast. We don't want to be heavily dependent on local cost of installation. So we prefabricated the components to be able to install them quickly on site with minimal work required, and get to a place where we can control the costs of the project very, very tightly, and also the performance. All of these are part of our latest design, the Vision Zero, and we're very excited about these numbers. You know, it's one thing to make a technology work. It's another thing to make it work and be very competitive, very efficient. And we have in Brenmiller are working very, very hard all the time to do that. And we have done everything to bring this product to the market in the right time for the market to accept it and install it. I'm going to try to provide a few additional updates. So we'll also talk about market and where we are in terms of not just technical development, but also manufacturing and ability to scale up and ramp up. So these are our models that are containing the storage media. For the ones who have not seen it before, there are 12-meter long models built at even smaller pieces. It looks like a pizza box. Each one of them contains storage media and the required parts to do all the heat exchanging, heat transferring, steam generation qualities. And this is what comes out of our production line. So in the past, we used to produce these models in the first projects in a more manual way. And today we are doing it in a much more industrious way. If you haven't been following us, we just a few months ago released our new production line in Israel. This is, I believe, the first of its world in this scale that can produce 4 gigawatt-hour of storage models per year, which is about $200 million in sales of storage models. You can see how it looks. This line is designed to do full automation in Industry 4.0 standards. And this is very important, not just to get to the right capacity of production, but also to the qualities and really contributing to the parameters that we just show. Because by doing this process very organized according to the standard automized, we can really increase also the capacity and all the other parameters which are critical, as I said, to get to a competitive solution. So you can see how the line looks now. This line was funded by the European Investment Bank, maybe the largest bank in the world for investment in such large infrastructure projects. The EIB has recognized our technology as one of the groundbreaking technologies and supported and financed this line. And our intention is to use this line in Israel for our global expansion. And once our pipeline is large enough in each specific continent, also to duplicate and install such lines and bring local jobs and local manufacturing to the countries which will implement and our solution. So this is the first one. We hope to see many more coming online in the next years. A few words about business models. So we are working in 2 main business models. One of them is selling the equipment. You can see the numbers here. We typically also sell with the equipment service agreements, which gives you support, optimization, warranty, maintenance. This is one that was quite significant in the last years. Another business model which becomes more and more dominant is energy as a service. So many companies today don't want to work and produce energy because they're producing something else. They're producing coke, they're producing chemicals, they're producing materials that are not energy, but they are energy intensive, and they prefer to buy energy, clean energy as a service and have it off their balance sheet. This is something that offers them the ability not to invest, not to take the risk, to operate, to maintain, especially when it comes to new technologies. And what we are doing is offering mainly with local partners, and you can see different names of partners that we work in locally and globally to provide a full solution from, for example, sun to clean steam as a service to a customer. And you can see the names we already announced we're working with, and we are also working on many new partnerships to expand and to really give us the ability to scale up for our sales activities and the size and scale of our project. So this is a very, I would say, important business model in our strategy. A few words without getting too technical about grid services. So we are, as I said before, also providing grid services using this application, this product. Very critical role we see in Europe, in the US, to balance the grid. We need more and more devices like this one. And we see in many projects that this service is critical to the grid and also to make us able to offer our clients a much cheaper cost for their heat because we have additional revenue streams. So this market opened up for us in the last couple of years and really created us with an opportunity to have cheap, reliable, clean energy to charge our unit and then supply also effective and cost-effective energy. And you can see in Europe, it's called AFRR. In the US, there are different demand response mechanisms, but the principle is the same. Relieve the grid in hours when there is excess renewable. Also the hours when the electricity is clean and green, and then supply the heat around the clock to our customers. You can see in this map our pipeline. We see a pipeline growing every year significantly. You can see the areas we are focused on in North America, Europe as the leading market, Brazil and India also are developed market we are working on. We just announced a new partnership in India. So we see a very significant growth in our pipeline in the last period. And you can see how it's spread globally here. Another thing that is now really was recently announced is the project we are now commissioning with Enel, a 24 megawatt-hour project in a combined cycle plant in Italy, in Tuscany, maybe, or the biggest one connected to a live gas power plant. And this is also a very important milestone for us, or having an organization like Enel installing, validating, and really showing this large-scale installation on their power plant. It's a very big milestone that we achieved in the way to fully commercialize our technology. I'll share a quick video for you just to understand how it looks when you build such a system at full scale. You can see how it's connected to this very large 400 megawatt power plant in Italy. You can see on the left how the modules are being placed one on top of the others. Very simple, as I said, relatively quick installation, very simple because there are no hazardous materials here, nothing that you have to worry that will explode or leak or freeze. And the idea in this project is to bring flexibility into this power plant. These power plants are dealing with changing conditions, more and more renewables in the grid. And these power plants need solutions like this to increase flexibility, to generate new revenue streams, like the ones we talked about, grid services. And Enel recognized this issue and chose us to install and integrate this into their power plant, which is a very, I think, a progressive way for a utility to go ahead and install such a scale. So we are very happy about this collaboration and the successful installation and operation of this unit. And we look forward, of course, to take this partnership with Enel and other strategic players and really build more and more projects like this around the world for different clients of ours, of Enel's, of our other partners. So we are very, very proud and happy of this installation. Okay. I'll give you another second to look at it. Okay. Okay. There are a few more additions here about what to expect soon. So we are in what we already announced. You can see here of projects in this field using this that will use the new product. One is for a leading beverage manufacturer in Israel, which is owned partially by Heineken. We already announced we received a grant for this project at 32 megawatt-hour Bijan in Israel. We also recently announced a partnership with one of the leading global utilities to decarbonize it. We are working a very large pipeline with them to do what we mentioned, and also with our partners in Europe, Green Genesis. And we see again in this field, our pipeline keeps growing and growing, and we see the demand also growing and growing from the market side all the time. I will summarize and try to leave a couple of minutes for questions, but it's really important for us to first thank you for coming and seeing our new product, which is meant to enable electrification of heat using renewable sources while supporting the grid. Thank you very much.
Thank you, Doron. So this presentation will be available online on our website in about 24 hours, in the next 24 hours. We'll go to some Q&A, and I want to thank Doron. I also want to share with you that we believe that as we published, we are just starting revenues. We are foreseeing few upcoming projects in the near term, and we see 24, 25 as the main breakthrough years. We've put in place the capacity to stand behind these sales and projects. No bank is financing such a capacity without seeing a business plan and a pipeline. I'm going to go to some questions. Okay, so I get many questions about capital. How do you get to finance energy as a service and all the finance structure? So we are working on partnerships and financing that are non-dilutive to all the activity that is not a headquarter activity. So the headquarter activity for the near term is going to be financed from capital we raised and capital that we will raise in the future. We believe that we can be balanced in 18 to 24 months. All the activity around projects is going to be financed in project level in a non-dilutive way. We are now working on these financing, on these partnerships. The role for the project finance is going to be on the partner. We are joining these huge companies because they have the balance sheet, because they have the access for finance. Most of the projects we are working on are being submitted to grants. There is a huge amount of grants today for clean energy decarbonization, both in the US and in Europe. And you can get all the way from 40 to 70% of grant on your CapEx. So that's in high level how we are going to grow. Today, the company burn rate, I'm answering again, is approximately $10 million per year. We expect it to not to rise and even be lower, because first we have revenues, and we are getting more and more effective, I would say, as we are now past the main R&D phase of the company. Of course, we keep some R&D, always working on the next generation, but the main challenge to put the first truly commercial technology is behind us, and this is why we'll get more efficient on budget. Just a second.
Nir, maybe I can answer a few questions about the market. So regarding the industrial sites, which are asking your solution, so it's mainly, I would say, large industrial companies that are using a lot of process steam, chemicals, pharmaceuticals, food and beverage, pulp and paper, These are typical clients that we look to implement this, especially ones which have significant ESG goals. They have to take care of, because, as I said, heat is 50 to 70% of their energy use. So if they don't decarbonize, they can't meet their goals. So the ones that are serious about it are the ones that are talking with us. We see also oil and gas companies recently becoming more and more active and looking for solutions to decarbonize their heat. Regarding the second questions, yeah, we have partners in Europe, both direct partners like GEG, which is a big developer of PV that we are working to supply together these solutions, either as an equipment or sale of energy, and also channel partners, as we mentioned, Enel or the other utility we mentioned, we're developing a pipeline with. All of these, mainly the major ones are EU-based players that are working with us. And we are developing more like, and this is the last question, like in India, we just announced a partnership with Worry Energies, the largest PV manufacturer in India, to also introduce and expand into the Indian market. And together with them, we are now building our expansion plan. So we are teaming up with really the first-tier companies, developers, to really implement this solution and give a full answer to their clients.
Yeah, another question is, when do you think you will be a profitable company? So I partially answered it. We'll be balanced in about 18 to 24 months, and then turning into profitability is also a matter of management decision where to further invest. But in terms of inflows coming that will enable us to be profitable, I foresee it for the next 18 to 24 months. I see here a question regarding, is there an interest to couple it with the PV field? Doron, do you want to take it?
Yeah, of course there is. I mean, when we say power to heat, we in many cases are looking at PV to heat or to steam, because when you want it, you mainly want it to be clean. So a big part of the projects we are working on with the utility is PV to steam. And an important or interesting number is that sometimes the amount of PV you want to install for a large industrial plant is maybe 5 or 10 times more PV than you would just install for its electrical needs. So this is a very huge opportunity also for the PV developers to increase their pipeline and consume the energy locally without the need to really have grid connections and transfer the energy for distances and build long grids. So this is a very big opportunity to those PV developers. Another question about cost of installation in India. So of course, cost depends a little bit, and it depends if we have local manufacturing set up or not. We are aspiring to get below $50 per megawatt hour in large projects, and then depends on the scale and the location. So depends on the larger scale. This is where we are standing today, and then we need to check locally. But this is just to give you an idea.
Maybe, Doron, I want to add to the question about the interest of adding PV. We are a young company with a new technology, and on the other hand, we have 4 major global PV players that have signed cooperation agreements with us. Most of the PV installations today are targeting corporate PPAs. They want to sell the energy directly to large corporates. And when you sell the electricity part, it's usually only 20% or 30% of this organization energy consumption, where heat accounts for the rest of the 70%, 70%. And we enable them just to sell significantly more PV or wind power to the corporates. I also wanted to add that there was a question about which organization are we targeting. Brenmiller, as a thermal storage company, targets the AAA organizations. It takes a little bit more time, but we are coming from corporates. We are working years with these utilities. We have the capability to sell the technology to these giants. So it takes a little bit more time, and the process is heavy and exhausting sometimes. But once you're in and you're a supplier of a AAA organization, a global corporate, they have hundreds of energy production sites globally, and we believe that it's a good investment to sell to these giants. So it takes more time for the initial sale, but the after sales are, we hope, will be beneficial for the company. There is a question about initial rollout cost. That varies dramatically on sizing, location, but as Doron mentioned, target cost today is around $50 per megawatt installed. I hope this answers your question. Okay, Doron and myself are always available for any question. You can contact us directly. We are available on our website. We always respond. This presentation again will be available on the investor website, and we really thank you for your time today. Looking forward for some exciting news in the near future. So have a great day, and thank you for joining us today.
Thank you.